Assalamualaikum warahmatullahi wabarakatuh and greetings to everyone. For this group assignment, we first present the title and course information. Our group title for this group assignment is Budgeting or Planning Problems with Constraint Inequalities. So let's go. We go to the next slide. Okay, followed by an introduction of our group members. We work together as a team contained of 5 members. Each member was assigned specific roles and responsibilities according to their own skills and strengths to ensure the project worked perfectly. Okay, for this group assignment, we want to present our group discussion for the our scenario. We outline the table of content, which first is section 1, introduction and problem statement. Second is section 2, model formulation, equation or inequalities. 3 is section 3, solution steps. And lastly, section 4, critical evaluation, like assumptions, limitations, and alternative methods.
Problem selection. Our scenario is School Club Snack Sale Fundraising. A school club wants to raise money by selling snacks during a school event. They plan to sell muffin and sandwich. They have a limited budget to buy ingredients and limited preparation time before the event. They must decide how many muffin and sandwich to prepare, satisfying all constraints while reaching a minimum fundraising goal. Purpose of the model: to determine how many muffin and sandwich the club should prepare so that they stay within their budget, they stay within their available preparation time, and they reach at least their target profit. B. Variables: X equal to number of muffins to make greater than or equal to 0. Y equal to number of sandwich to make greater than or equal to 0. Parameters. Number 1. Cost to produce. Ingredient cost for muffin is 1 ringgit 20 cent each. Ingredient cost for sandwich is 2 ringgit each. Number 2. Selling price. Muffin sell for 2 ringgit each. Sandwich sell for 3 ringgit each. Number 3. Preparation time. Muffin took 3 minutes each. Sandwich took 5 minutes each. And the total preparation time is 600 minutes. Number 4. Total ingredient budget. Maximum ingredient spending is 500 ringgit. Lastly, minimum profit target. To earn at least 200 ringgit profit, muffin profit per item is 80 cent and sandwich profit per item is 1 ringgit. Next is constraint. Number 1. Ingredient budget. 1.2x plus 2y less than or equal to 500. Number 2. Preparation time. 3x plus 5y less than or equal to 600. Number 3. Minimum profit. 0.8x plus 1.0y greater than or equal to 200. Number 4. Non-negativity. X greater than or equal to 0. Y greater than or equal to 0. What needs to be found in this problem? Number 1. The values of muffin and sandwich that satisfy all inequalities. Number 2. These values represent all possible production plans that meet the budget, time limits, and the profit target.
The mathematical modeling phase is crucial process where a real-world resource allocation problem, such as determining the optimal production volume with available resource, is translated into an abstract, solvable mathematical model. The primary purpose is to structure this complex scenario into a set of equations and inequalities that can be systematically analyzed to achieve the most optimal decision. The analysis of the situation reveals that the main objective is to optimize the outcome, in this case maximizing profit subject to clear resource limitation, specifically budget and time constraints. This type of situation classically requires a linear programming model. The structure of this model fundamentally involves define one objective function, what is to be maximized, and multiply inequalities constraints that represent the boundaries of the available resource. In this model, two decision variables are defined: X, which represent the number of muffins to be made, and Y, which represent the number of sandwiches to be made. Both of these values must be non-negative, greater than or equal to 0. The main goal or objective function is to maximize profit P based on a profit of 8 cents per muffin and 1 ringgit per sandwich. The objective function that needs to be maximized is where the profit P is equivalent to 8 cents multiplied by the number of muffins added to 1 ringgit multiplied by the number of sandwiches. The linear programming model is chosen because it is the most efficient method for optimally allocation limited resource in a business context. Its effectiveness relies on the assumption that all key values, cost, time, profit, are constant and therefore from a linear relationship. The strategic use of inequality symbol is essential. The less than or equality symbol is used to ensure finite resources like budget and time are not exceeded, while the greater than or equal to symbol is used to ensure a minimum profit target is met or surpassed.
On this slide, I will provide a detailed explanation of all the constraints involved in this problem. Each constraint represents a real-world limitation, and together they form the mathematical model. We begin with the budget constraints. The inequality is 1.2x plus 2y is less than or equal to 500. This means that when we combine the cost of producing muffin and the cost of producing sandwiches, the total must not exceed 500 ringgit. This ensures that the club stays within the available ingredient budget. Next, we look at the time constraints written as 3x plus 5y is less than or equal to 600. This inequality shows that the total preparation time must not exceed 600 minutes. Each muffin and each sandwich require a specific amount of time to prepare, and these constraints prevent the club from exceeding the allotted time. The third constraint is the minimum profit requirement written as 0.8x plus y is greater than or equal to 200. This tells us that the combined profit from muffin and sandwiches must be at least 200 ringgit. So, even if the production stays within budget and within time, it still must achieve this minimum profit target. Finally, we apply the non-negativity condition, which states that x must be greater than or equal to 0 and y must be greater than or equal to 0. This is important because it confirms that the quantities of muffin and sandwiches cannot be negative. On the right side of this slide, we show the x and y intercept for each constraint. This intercept tells us where each boundary line touches the axis. For the budget constraint, x equals 416.7, y equals 250. For the time constraints, x equals 200, y equals 120. For the profit requirement, x equals 250, y equals 200. When we compare this value, We can clearly see that the time constraint has the smallest intercept. This means time is the most restrictive constraints, and it will play the strongest role in limiting production. On this slide, we evaluate the feasible points that lie on the time constraint. We focus on this boundary because, based on the previous slide, the time constraint is the tightest and therefore the most influential limit. The first point we check is x equals 200 and y equals 0. This represents the scenario where the club produces muffins only. To examine whether these points satisfy the profit requirement, we calculate the profit. 0.8 multiplied by 200 gives 160 ringgit. The minimum required profit is 200 ringgit. So this point does not meet the requirement. This outcome is important because it shows that even the club used all available time to produce muffin, the resulting profit is still insufficient. The second point is x equals 0 and y equals 120. This represents producing sandwiches only within the 600-minute limit. The profit at this point is 1 multiplied by 120 equals 120 ringgit. Once again, this value is below the required minimum of 200 ringgit. Therefore, this point is also not feasible. On the right side of the slide, it is clearly shows that both points selected from the time constraint fail to achieve the required profit. Although a theoretical algebraic solution suggests that x could reach 400, the time constraint limits the actual maximum to 200. This confirms that time is the critical restriction that prevents higher production and higher profits. The overall findings show that there is no feasible solution that satisfies the budget limit, the time limit, and the minimum profit requirement simultaneously. The 600-minute time limit is the most restrictive constraint, and it prevents the club from producing a large enough quantity of item to reach the target profit of 200 ringgit. Under the current condition, the profit requirement cannot be met. To achieve the target, either the club would need to additional preparation or the minimum profit requirement would need to be adjusted to a more realistic level. This conclusion explains clearly why the model is infeasible and what change would be needed to make the objective achievable.
For this slide, I will explain our critical evaluation. It has three parts. First, assumption. Second, limitation. And lastly, alternative method. First, for the assumption, we assume all muffin and sandwich can be sold. Second, the ingredient cost and selling price stay the same. Lastly, the preparation time for each unit is fixed. This assumption helps us make the model easier to calculate. Next is the limitation. First, real customer demand is not certain. Second, kitchen capacity and equipment limit are not included. Lastly, ingredient price can change over time. Because of this limit, the real result may be different from the model. For alternative method, we suggest three methods. First, sensitive analysis. Sensitive analysis to test how results change if cost or price change. Second, demand forecasting. Demand forecasting to predict real demand using past data or estimate crowd size. Lastly, simulation. Simulation to test different real-life situations. So, this method can give more accurate data. In summary, this critical evaluation helps us to see what is accurate in our model, what is limited, and what method can improve our analysis.
So this is feasibility discussion from our critical discussion. The mathematical result conclude no feasible solutions. Through critical evaluation, we confirm this outcome logically. First, even under ideal assumptions, the time constraint prevent reaching RM200 profits. Second, any realistic violation of assumptions, lower demand, price fluctuations, and slower prep time makes feasibility even worse. Therefore, the model's conclusion is not only mathematically correct but also practically valid. Okay, lastly, our conclusion for this group assignment is drawn after reviewing all the equations, constraints, and solution steps to determine whether the club could realistically meet the budget, time, and profit requirements set in the model. The findings show that none of the possible production plans can satisfy all three conditions at once, as the limited preparation time makes it impossible to generate enough profit to reach the RM200 ringgit target. Okay, so that's all for our group presentation for this group assignment. Thank you everyone for your listening and for your cooperation. Thank you again and bye everyone.